radians to degrees. So we've got pi over 180 degrees times 60 degrees. The degrees cancel out, and the 180 and 60 degrees equals 1 over 3. So then you get 1 pi over 3. That's converting degrees to radians. Converting radians to degrees, you would use the equation 180 degrees over pi times pi over 4. The pi's would cancel out, and you would be left with 45 degrees.
Hi, I'm Thomas, and I'm going to be teaching about arc length. The arc length formula for a degree measure is if theta is equal to a central angle in a circle with a radius r, and if theta is measured in degrees, then the length s of the intercepted arc is given by the formula s equals pi r theta over 180. So the example we have here is a slice of pizza, which is cut into 60 degrees and is 7 inches long, and we're trying to find s in inches, or like the crust. So you plug that in, and it's s equals pi times the radius, which is 7 inches, times 60 degrees, or theta, over 180 degrees, which is equivalent to 7 pi over 3, or 7.3 inches. The second, equation would be arc length formula for in radian measure, which is if theta is a central angle in a circle of radius r, and if theta is measured in radians, then the length s of the intercepted arc is given by the formula s equals r theta. So s equals r theta here, and you're given the radius is 2 inches and theta is 25 radians. How would you find s? Well, when we plug it in, you multiply 2 times 2 inches times 25 radians, and it should come out to be 50 inches.
That's pretty easy. Huh. Huh. Pretty easy? Mm-hmm. Yeah? Pretty easy.
Yep.
Cool.
This is 4.1 angular and linear velocity. Have you ever turned your bike upside down and spun the wheels?
Yeah.
You wonder how fast the wheels will spin or how fast the bike will go?
No.
Well, we'll show you today with today's lesson. The equation for angular velocity is very simple. It is omega equals theta over time. Angular speed being omega is equal to the amount of rotations per unit of time. Sometimes in questions they ask for revolutions, and that is when you simply multiply theta by 2 pi.
Once you find angular velocity, you are then able to find linear velocity, which is the movement of the entire object. Its formula is v equals radius times omega. It's measured in miles per hour, feet per second, and centimeters per minute.
To solve problems like these, you need to use both the equations. That's it?
Of angular and linear velocity.
Okay. Problems like these, you need to use both equations for angular and linear velocity.
The example says, given a tire with a diameter of 26 inches, find the speed in miles per hour when the wheel turns 200 revolutions per minute.
As you can see, omega is already given to us in revolutions per minute, so you can start out by doing 200 revs over 1 minute.
And now you have to convert, and so you have to multiply by 60 minutes over 1 hour to get rid of the minutes. Then you have to multiply by 2 pi radian over 1 revolution. And then you multiply by 13 inches over 1 radian. And then you multiply by 1 foot over 12 inches.
We're running out of room there.
Oh.
Okay, and then multiply by 1 mile over 5,000.
5,280 feet.
It's tiny.
It's good. So from there, we're able to cancel out everything to get from revolutions per minute to miles per hour. That's problem correctly. Your final answer should be 15.46 miles per hour.